Okay, part A, simple familiar. What is the largest angle of the triangle? So we've got sides A, B, C. You should be familiar with how you work that out. A is opposite to angle A, B is opposite to angle B, etc. Now, we've got every side, the value for every side, but we've got no angles, so we can't use sine rule for this. It's a cos rule problem. So let's find angle A first using cos rule. So cos A equals B squared plus C squared minus A squared, all on 2BC. And that equals 6 squared plus 7 squared minus 8 squared, all on 2 times 6 times 7, equals 0.25. So A equals the cos inverse of 0.25, you should leave that in your calculator without rounding it off, equals 75.52 degrees. Now we go on to find cos B equals A squared plus C squared minus B squared, all on 2AC, equals 8 squared plus 7 squared minus 6 squared, all on 2 times 8 times 7, and that'll get you 0.6875. Leave it in the calculator. B equals the cos inverse of that value, which will give you 46.57 degrees. Now we've found two angles. We know that all angles of a triangle add up to 180, so A plus B plus C equals 180. So C is equal to 180 minus A minus B equals 180 minus 75.52 minus 46.57. So C equals 57.91 degrees. Therefore, the largest angle is A. Okay, question 2. If matrices A, B and C are order 2 by 2, 3 by 1 and 2 by 3 respectively, the product of which matrices will give a 2 by 1 matrix? Okay, straight away, to finish in a 1 matrix, then something's got to be multiplying by matrix B, which is a 3 by 1. So what is this one? So to make it so it's defined, it's got to be something times 3, so that these are the same. And so the only option there is a 2 by 3, which is C. So the answer is C times B will give a 2 by 1 matrix. The formula to find the new speed V when you know starting speed U, acceleration A and distance travelled S is as follows. V squared equals U squared plus 2AS. Rearrange to find distance travelled. Okay, firstly, we need to leave this all together until we get the U across. So bring the U across as a negative. We want to get S by itself. So V squared minus U squared equals 2AS. Now we can bring the 2A across to divide. So we end up with S is equal to V squared minus U squared, all on 2A. Solve for A. So firstly, let's look at the order of these. So this is 3 by 2. Remember, you do rows by columns. This is 2 by 2, and this is a 3 by 2. Now, you need to do the multiplication first. It is defined because the inner numbers are the same, so you'll end up with a 3 by 2 matrix. Now, this matrix needs to have the same order as this one, which is correct, so we can work it out. Firstly, we do this multiplication. So we're looking at the first row and the first column. So we've got 2 times 2 minus 6 times 1 because of this negative. So 2 times 2 minus 6 times 1, or you could say plus 6 times negative 1. And then we've got working with the same first row but now with the second column. So we got 2 times 5 plus 6 times 0 . Then working with the second row and first column, we've got 0 times 2 plus negative 2 times negative 1. Negative times negative is a positive, so it's plus 2 times 1. Then we're working with that same row and the second column, so 0 times 5 and negative 2 times 0, which is 0. Then looking at this third row and first column, we've got negative 3 times 2 is negative 6. And then 1 times negative 1, which is negative 1. So let's just go ahead and say minus 1. And lastly, third row and second column, negative 3 times 5 is negative 15. And then 1 times 0, so it's plus 0. Now we need to subtract this matrix here. So 2, negative 2, 4, 0, negative 1, 1. Now we're not doing that yet, but we're just keeping this in the equation. And that equals, let's just work out each one of these. So we've got 4 minus 6 is negative 2. We've got 10 plus 0, 10. 0 plus 2, which is 2. Then we've got 0 here, negative 7, and negative 15. And then again, you carry this across to subtract. Now we go ahead and do this. Now remember with subtract, you just subtract the first item with the first item. The first row column 2 with the first row column 2, and so on. So A equals negative 2 minus 2, which is negative 4. 10 minus negative 2, so when you got minus negative, it turns into a plus. So it's 10 plus 2, which is 12. Now you're looking at this one, 2 minus 4, which is negative 2. 0 minus 0 is 0. Negative 7 minus negative 1 is the same as negative 7 plus 1, because two negatives cancel. So it's negative 6. Negative 15 minus 1 is negative 16. Alright, use Heron's formula for area of a triangle with sides 7.2 centimeters, 6.1 centimeters, and 9.5 centimeters. With Heron's rule, you need to find the semi-perimeter, which is a half of sides A plus B plus C, half the perimeter, equals a half of 6.1 equals a half of 7.2 plus 6.1 plus 9.5, which equals 11.4 centimeters. Now the area, Heron's formula, is equal to the square root S times S minus A times S minus B times S minus C, which equals the square root of 11.4 times 11.4 minus 7.2 times 11.4 minus 6.1 times 11.4 minus 9.5. That equals the square root of 11.4 times 4.2 times 5.3 times 1.9 equals the square root of 482.1516. And finally, area equals, let's just say that area equals 21.96 centimeters squared. Okay, find x. Now straight away we can see we've got an angle, and we know the opposite to the angle, and we need to find the adjacent. So that's a tan problem. So tan 15 is equal to 14 on x. Now we want to get x up the top, so we bring it across to multiply. So x tan 15 is equal to 14. Now bring the tan 15 over to divide. So x equals 14 on tan 15. And that equals 52.25 centimetres. Students 1, 2 and 3 had their marks reviewed across their 3 core subjects. Results were as follows in consecutive order. Maths 20, 18, 19. English 19, 20, 20. Science 18, 19, 18. Construct a matrix to display the data. Let's set up a 3 by 3 matrix because we've got 9 data sets, and let's say students, student 1, student 2, student 3, and this will be maths, English and science. Okay, now student 1 had those results, so for maths it's 20, English is 19, 18. Student 2 had those results, so we've got 18 for maths, 20 for English and 19 for science. And student 3 is 19, 20 and 18. Okay, we've got a triangle. They've given us side C and side A, and they've given us angle A. And part A is find angle B. So straight away we can recognise we've got an angle, we've got 2 sides, one of them is opposite to the angle, so we can use the sine rule. So A on sine A is equal to little c on sine C. Now I know we're not finding B in this case yet, which is what we need to find, but it's easy to find B once we know A and C. So rearranging to get C, angle C on top, we'll bring this over to multiply, and we can bring that over that side to multiply. So A sine C equals C sine A. Bring that over to divide. Sine C equals C sine A on little a is equal to 12 times sine 110 divided by 14. Now put that in the calculator and you get 0.805. So C equals the sine inverse. Make sure you leave that in your calculator to avoid round-off errors. And that'll give you 53.65 degrees. Now we know 2 angles, we can find B because all angles of a triangle add up to 180. So A plus B plus C equals 180. So B equals 180 minus 110 minus 53.65. B equals 16.35 degrees. So let's go ahead and put our values in. So this is 16.35. This is 53.65. So now they want us to find the area of the triangle. Now we've got this angle and we've got 2 adjacent sides. So we can use the area equals a half AC sine B equals a half times 14 times 12 times sine 16.35, and that equals 23.65 centimetres squared. You're going to invest money. The amount your investment will grow to is calculated by A equals P times 1 plus R on 100 to the power of N, where P is the principal amount, N is the number of years, R% is the annual compound interest. A, find the value of the investment if you invest $10,000 at 5.25% per annum for 6 years. B, if you invest a different amount at 7.25% and it grows to $50,339.98 over 10 years, what is the interest earned after 2 years? Okay, part A, they want to know the value of your investment if you've invested $10,000 at 5.25% per annum after 6 years. So A equals P1 plus R on 100 to the power of N. Now we just substitute all our values, so P equals 10,000 times 1 plus R is 5.25 on 100 to the power of 6, because it's 6 years. Now going ahead and calculating that, you will get 13,593.54. So part B, if you invest a different amount at 7.25 and it grows to $50,339.98 over 10 years, what is the interest earned over 2 years? So we need to know the different amount, which is the principal, so we need to rearrange the equation. So what we can do is we can bring this over to divide. So P is equal to A divided by 1 plus R on 100 to the power of N. So substituting in the values, we've got P equals, A is the new value, so that's 50,339.98 divided by 1 plus the interest rate, 7.25 on 100. And it's grown over 10 years. Now if you go ahead and calculate that out, you'll get 25,000. So now we know the principal, we can find out what A is after 2 years with that same interest rate. So it's 25,000, subbing it into this equation again, times 1 plus this, it's 7.25% to the power of 2, because we're talking about 2 years now. What is the interest earned after 2 years? So the value of your investment is 28,756.40 after 2 years. And so the interest earned is equal to A minus P, which is equal to this value minus this value, and that is $3,756 interest earned. Alright, solve the unknowns. Firstly, we do the scalar multiplication. So we've got 2y plus 2, 4, 2 2s are 4, 2 4s are 8, and 2 times x is 2x, plus 2 minus 6 minus 5y, we just carry that across because we're not doing that yet, 6x minus 2, 3, 7. Now we can expand these out. So 2y plus 4, 4, 8, 2x, 2, that's plus 2, negative 6, negative 5y. Let's just move these across a bit so they don't look like they're actually sums. Equals 6x minus 2, 3, 7. Now we can perform this calculation here, the addition of the two matrices. Remember, you add that plus that, then that plus that, then that plus that, and then that plus that. So we've got 2y plus 4 plus 2, so that's 2y plus 6, 4 minus 6 is negative 2. 8 minus 5 is 3. And 2x plus y. And that equals 6x minus 2, 3, 7. Now we already know negative 2 equals negative 2 and 3 equals 3, so that's useless information, so we can cross that out. So we've got what's remaining, we've got 2y plus 6 equals 6x. Let's bring that across as a minus, so 2y equals 6x minus 6. Now we can divide everything by 2, which gives y equals 3x minus 3, and we'll call that equation 1. Now lastly, we've got a second equation here, 2x plus y equals 7. So 2x plus y equals 7. Call that equation 2. And we'll use the substitution method, sub 1 in 2. So we've got 2x plus, now put this in for y, 3x minus 3 equals 7. Bring that over as a plus, and we can add the like values, so 5x equals 10. Bring that over to divide. X equals 10 on 5, which is 2. Now we sub in 1 to find y, so y equals 3 times x, which is 2, minus 3, equals 6 minus 3, which is 3. So they're your two values, y equals 3, x equals 2. A developer has a rectangular block of land 50 metres by 100 metres in size. He has an opportunity to increase the block, which can be extended by marking out an equilateral triangle that includes the diagonal, corner to corner, of his existing block as one of the sides. Draw a diagram, and what is the new total area? He's got a rectangular block already, and it's 50 metres by 100 metres. Now, he can extend it with an equilateral triangle shape that includes the diagonal, corner to corner, of his existing land. So what do we know about equilateral triangles? Every angle is the same and they all add up to 180, so it's 60 degrees. Now, we can also find this angle here, and we can find this angle here because we know that this is a 90 degree. So the area that we're working out is this total area. What is his new land area if he purchases that new section? So the easiest way, knowing that we know this is an equilateral triangle, all these sides are equal, so we only need to find the hypotenuse here of this triangle to work out the area of this equilateral triangle. So we call that A1. And to work out the area of this triangle, we'll call that A2. And we know we can work that out by half base by height. And then we just need to work out what the area is for this little triangle here and add it on. So let's work out A1. Now, for A1, we need to know the hypotenuse of the which is the diagonal length. Let's call it x. And using Pythagoras, x squared equals 50 squared plus 100 squared. So x equals the square root of 50 squared plus 100 squared equals 111.803 metres. Now we use Heron's Rule to find the area. So we've got to find the semi-perimeter first. We know it's a triangle of length of 111.803 on all sides because it's equilateral. So the semi-perimeter is a half times 3 times 111.803 meters, or it's the same as adding that up 3 times and halving it, and that equals 167.71 meters. So area 1 is equal to the square root, this is Heron's rule, s times s minus a, s minus b, s minus c, and that equals the square root of 167.71 times, now because each one of these is the same, we can just say 167.71 minus 111.803 cubed. So A1 is equal to 5,413.51 meters squared once you calculate that out. Now we find A2. A2 equals a half base times perpendicular height, which equals a half times 100 times 50, and that equals 2,500 meters squared. Now we need to find, we know this height for this triangle to find the area. We need to find this angle here, and to do that we need to find this angle here. So we'll find theta first, because we know this opposite and we know adjacent. So tan theta equals opposite on adjacent, which is 50 on 100. So theta equals tan inverse of 0.5 equals 26.57 degrees. We know this angle now, we'll call it alpha, and we know it's 90 degrees minus 26.57 minus 60 degrees, because they all need to add up to the right angle triangle, and that equals 3.43 degrees. So let's find the opposite. We know the adjacent value. Let's find this value of the triangle, of the tiny triangle. So we'll call this y. So tan alpha is equal to opposite on adjacent, which is y on this value here, which is 50. Bring that over to multiply to get y on its own. Y is equal to 50 tan alpha, which is 3.43, equals 2.997 meters. So area 3, that's that tiny triangle, is equal to a half base times perpendicular height, equals a half times 50 meters times 2.997, which is the value of y, and that equals 74.93 meters squared. So now we've got A1. A1 is that. We've got A2 is that. And we've got A3, this little tiny triangle, is that. So now we just add them up, and that's the total new area. So you get A1 plus A2 plus A3 is equal to 5413.51 plus 2500 plus 74.93 equals 7,988.44 meters squared, and that's his new area of land that he would have. A room is rectangular prism in shape, and a renovator measures the longest diagonal between corners as 10 meters. That's front bottom to back top corner. The same diagonal has an angle of depression of 20 degrees with the ceiling. If the front wall has a diagonal corner to corner brace of 5 meters, draw a diagram with relevant information and find the dimensions of the building. Okay, so firstly we draw our rectangular prism. Now we've been told that he's measured from the front bottom to the back corner, so that would be this, and that's 10 meters. Now that same diagonal has an angle of depression of 20 degrees. Now we've got to make sure we're in the plane of that diagonal, in a triangle in the plane of that diagonal, which means that we use that line there as our adjacent to this angle, which is the angle of depression, and that value there is 20 degrees. So this is a right angle, and the 10 meters is a hypotenuse. Now it says if the front wall has a diagonal corner to corner brace of 5 meters, so this is what they're talking about there, and that's 5 meters long. Now these are both right angles. Draw a diagram with relevant information. So that gives us all the details we've been given. What don't we know? We don't know H, we don't know L, and we'll call this W. Okay, firstly we can find H straight away because we've got two pieces of information for this triangle here. We've got the hypotenuse and we've got the angle. So we can say we're finding opposite. So we've got sine theta is equal to opposite on hypotenuse. So sine 20 equals H on 10. That comes over to multiply, and that gives us H equals 10 sine 20, which equals 3.42 meters. So put that in here, 3.42 meters. So now we know for this triangle we've got two pieces of information. We've got H equals 3.42 meters, and we know the hypotenuse is 5 meters. So using Pythagoras we can find W. So W squared plus H squared is equal to 5 squared. W squared plus 3.42 squared equals 5 squared. That comes over to minus, so W equals the square root of 5 squared minus 3.42 squared equals 3.65 meters. So this is 3.65 meters. So now we can also recognize we've got a right angled triangle here, where we know 5 meter side, we know the 10 meter hypotenuse, and we need to find L. So it's a simple Pythagoras theorem. So L squared plus 5 squared equals 10 squared. L squared equals 10 squared minus 5 squared, because that comes over as a minus, which equals 100 minus 25, which is 75. So L equals the square root of 75 equals 8.66 meters. So the dimensions are 8.66 meters long by 3.65 meters wide by 3.42 meters high.